Hey, welcome back to our Facebook LeetCode interview series here on the Web3 Idiot. Today we're going to be tackling question number 71, simplify path. So we're going to be going through some of the most frequently asked Facebook interview questions according to LeetCode, and this is one of them, number 71, called simplify path. So given an absolute path for a Unix style file system, which begins with a slash, transform this path into its simplified canonical path. So if you've been able to, learn a bit of navigation through your command line, this shouldn't be too difficult. But if you've never done that before, this may be a little more challenging. So in Unix-style file system context, a single period signifies the current directory. So if we see a period, we don't go anywhere. If we say a double period, we move up one directory level. So for example, we'll talk about examples later. And multiple slashes are interpreted as a single slash. In this problem, treat sequences of periods not covered by the previous rules, like triple periods, as valid names for files or directories. So if we see a triple or a quadruple period name, we're just going to treat it as a file name. The simplified canonical path should adhere to the following rules. Start with a single slash. So there we go. We know that we want to start off with a slash. So we'll go ahead and just get that there. Directories within the path should be separated by only one slash, okay? It should not end with a slash unless it's the root directory, okay? Easy peasy. It should exclude any single or double periods, okay, blah, blah, blah. So here we have this element here. We have a /home and then another another slash, and our output is just a slash plus home. We're getting rid of the last slash. Trailing slash should be removed. Pretty easy, pretty straightforward. Here we have a double slash that we need to turn into a single slash and also remove the trailing slash. Here we have a slash, a home, a slash, user, slash, document, slash, a double. So this double means that we're going up a level, which means we should get rid of this documents here. So it should be slash home, slash user, slash pictures. And that is what we actually do. All kinds of double. So here we have 3 periods, which means we treat it as an actual file name. We have this double, so we get rid of this A here. Then we have B, C, and then we have another double, so we get rid of this C. And then we have a D and a period, but we get rid of this period. So what we end up with is a slash triple period slash B slash D. So basically, there are just a couple set of rules, and this is going to be a classic stack problem. So let's go ahead and set it up. So our constant stack is going to be equal to this thing here. And then we're also going to go through and clean up our input. And by that, I mean we're going to be splitting it up based on our slashes. And we also need to take into account there might be a double slash, which means there will be, in this array, an empty value. So we need to get rid of that as well. So for now, let's go ahead and get into it. So we'll say constant, our new, we'll call it our clean path, is equal to our path.split. Oh, excuse me. We're going to be splitting it on the slash. And then we're going to filter. And what are we doing? We're filtering out all the empty values. So I'll go back through and give you an example of this in a second. And we're looking for where value actually has a value. So an example of this would be, let's go ahead and, not this one, it would be this one here. So here we go. So on the split of this slash, what this would actually become would be home. And then we have this slash and another slash. So we're splitting up, and then in between will be an empty value. It would be like that, and then we'd also have foo. So what this here does is make sure is that we grab elements that actually have a value. So we'd get rid of this, and in the end we would just end up with home and food. All right, and then from there what we need to do is loop through all of these values that we now have. So we'll say for let I equal 0, I is less than our clean path dot length, and we need to increment our I. And there are two rules that we saw, the double period and the single period. So if our clean path at I is equal to a double period, what we want to do is remove the element before. So we're going to be pushing everything to the stack. So what that actually means is we're going to be popping off the stack. So we'll go stack.pop because we're removing the last element we added to the stack if we see this double period here. Else if we see our clean path at I is equal to a single period, if we see a single period, we do nothing. That's just nothing, so we're not going to add it to the stack. We're just going to continue. And then finally, our last one is if it's any words or if it's any number of periods, what we want to do is say stack.push our clean path at I. And then when we get down here, blah, 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 we go through all that. So we are going to be returning our / plus our stack.join, and we are joining it with our slash. So yeah, pretty straightforward. Let's go ahead and go through an example. Maybe we'll use something like this. I'll go ahead and put that up here. So right now, this is our input. We have a slash, a triple period, a / an a slash, a double period, a B, a slash, a C, a slash, and a double period. So what this is actually going to end up being, we are expecting it to become /123/B. That's all we are expecting. So we're going to come over here. We're going to go ahead and clean this up. So what our clean path would end up looking like would be a triple period, an a double period, a B, a C, and a double period. So then what we're going to do is loop through this clean path here. So we're going to go ahead and take a look. We're going to say clean path at I is equal to double period. It is not single period, no. Then we're just going to push it to our stack. So right now, this stack has a triple period on it. Next up, we move over to our A. It is not double period, not single period, so we end up pushing it to our stack. So here we go. We have our A here. Next up, we hit a double period. So that is when we pop off the stack, which means the last element is now gone. Then we hit a B. We move on to this one here, B. It is not double period, it's not single period, so we push it to our stack. So B is now on our stack. Then we hit our C. It is not double period, not single period, so we push it to the stack. So here we go. And then we hit our last double period, and that means we pop off the last element from our stack. So there we go. The only two items left on our stack after going through all of these would be the triple period and the B. So I'm going to go ahead and snag this real quick and bring it down here, just so we can see how this wonderful thing works. So what this is actually going to become would be a / plus our stack.join. So our first one will be 1, 2, 3, and then we join it with the next one, which will be a / and then a B. And that is how we end up getting this expected value here. I'm going to go ahead and run it just so you can see how it works and see that it, see how that it actually works, better statement. And let's go ahead and run it. We pass all of our test cases, very good. And as far as time and space goes, stack could be O of n, so our space complexity would be O of n, where n is the number of elements in between our slashes. And then our time complexity here, we have O of n, O of n, O of n, O of n. So it'll just be O of n for time complexity as well. So pretty straightforward. If you have any questions, please post them below. I'll be more than happy to help you out. Please like, subscribe, and share it with a friend if you think they would enjoy this. Anyways, that was number 71. Let's submit. And that was number 71, simplify path. And here we are very average. So we'll take it. Anyways, have a great day and thank you.